Okay, good morning. Wow, that's loud, isn't it? Good morning. My name's Elton. I work for Docker. Thank you for joining me. This session is about modernizing legacy .NET applications. We use the word traditional usually rather than legacy, because if you go somewhere and say, let's have a look at this legacy application, and they say, that's not legacy, our entire business runs on that. So we tend to use the word traditional, but legacy works just as well. So today I'm going to be talking to you about existing applications, full .NET framework applications, how you can take them from whatever your current deployment process is and move them into Docker. So I joined Docker about a year ago, and before that my history was as a consultant, as a .NET consultant. Spent 15 years working on big .NET projects. I know the problems of deploying and managing and building those projects. And when Docker came along, I thought this is fantastic. This is a much better way of doing things. I'm going to try and give you an example today of why it's so much better. So I'm going to talk very quickly about the Docker platform, what it looks like, how you move apps into Docker, and then most of the session is about modernizing applications. So what I'm going to do is I'm going to take an existing traditional application, a monolithic application, I'm going to move it into Docker, and then I'm going to break features out. I'm going to break features out by some sort of value criteria, not a full re-architecture, not just a structural change, but adding actual features, breaking them out into different containers. I'm not going to be talking about any of this stuff. So actually, Docker has a history with the microservices movement and with DevOps and with all that stuff, and it's great. And if you're moving to Docker, it really helps you. Move to new architectural designs, new ways of working. It can help you move to the cloud. You can start using different technologies like .NET Core and Nano Server and Linux. I'm not going to be talking about any of that stuff because you don't need to do any of that. So this could be further on down your roadmap, and the beginning is just taking your big monolithic application and running it in a container. And there are benefits just for doing that. Okay, so very quickly, I've got an empty server here. So I'm going to talk very briefly about what Docker is. Can I have a quick show of hands? Who's heard of Docker? Everyone's heard of Docker. Okay, who's used Docker? That's probably about 40%. On Linux? Now we're getting smaller and smaller. And on Windows? Okay, cool. So for the people who didn't put your hands up at all, this slide is for you. So what Docker is, it's an application platform. It's a way of running applications. So instead of deploying like an MSI and starting an XE, you're going to run your application in a container. So what you do is you start off with your server, which could be a Windows server or a Linux server. You install Docker on it, which runs in the background. It's a Windows service or it's a Linux daemon, and it just runs there. You don't install any other software on your server because all the software you run will be through Docker. So if you want to start a web application, you run it in a container. If you want to start a background process or a batch job or a database, you run them all in containers. So you're going to send commands to Docker to start those applications, and Docker will run them. And what actually happens is the container itself is an isolated unit. So inside each of those containers, the application thinks it's got its own server. It thinks it's got a host name, it's got an IP address. They're all virtual things that Docker provides, but it thinks it's got its own server. It's got a file system, it's got its own registry, it can do whatever it wants. But actually, the processes that are hosting that application are running directly on the server. So if I've got a web application running here in IIS, I don't need IIS installed on the server because everything that the container needs comes in a package, and then all it does is it uses the host compute to run the actual XE. Same with this console application and SQL Server. I don't need anything installed here except Docker. Everything else comes in the package. And the reason that's useful is because you get a lot more density. I can run a lot more applications in containers on my server because there's no big layer in between. So traditionally, if you've got a virtual machine, I've got my application here, I've got this huge fake machine, which is my VM, and then I've got my actual machine. And the layer in between is expensive. If you can cut that out, which is what Docker does, you can run a lot more applications a lot more efficiently. Okay, so I'm going to start by showing you just very quickly how that looks. This link here, all the demos I'm going to show you are on GitHub. I've got a repo there with all the source code and also a little cheat sheet that reminds me what to do. And you can, I saw that. Here you are. If you can do this yourself, all you need is Windows 10 with Docker installed. Okay, so I'm using a Mac, obviously, because I like to complicate things. The Docker command line, Docker whatever, is in two parts. It talks to the Docker service. So in my case, I've got a virtual machine running on my Mac, which is running Windows Server. I've got Docker installed on my Windows Server machine, and on my Mac, I'm pointing to my VM. So when I run Docker version, I can see my client is Darwin, so I'm running on the Mac, but it's talking to a server which is running on Windows. So that's my Windows machine. Okay, if you're running Docker for Windows on Windows 10, you don't need to worry about that. It gets all set up for you. Okay, so the first thing I'm going to do is just run a web server. So, what this statement does, Docker container run me a container, run me an application inside this isolated unit called a container. The detach flag means put it in the background, so it's going to run like a Windows service. The publish flag means send some traffic into the container. So when you start a container by default, no traffic gets in. It's a bounded unit. But you can publish ports. So what I'm saying here is when any traffic comes into my VM on port 8081, route it into the container on port 80. So the container is a standard IIS web server. It's listening on port 80, but I'm routing from 8081 into there. And the last part is the name of the application to run, which is Microsoft/IIS. So what that is it's Windows Server Core with IIS installed, and it's owned by Microsoft. It's a publicly available free package. You can run this command on your own machine. If you don't have that package available, Docker will download it, and then it will start the container from that package. So the behavior wherever you run this will be exactly the same. Okay, so if I go to my VM and just prove to you that this is real, this is the IP address of my virtual machine. So now when I browse to port 8081, 8081. That's IIS. So that's running inside a container. So what's happened there is Docker has intercepted the network request on 8081, routed it into container, the container's processed it and sent it back. So it's just like starting up a virtual machine, but somebody else is taking care of making sure your Windows is up to date, installing IIS, and distributing it. So that's owned by Microsoft. So it's nice and easy. The second example, a little bit more, a few more words in this one. So what I'm going to do here is I'm going to run SQL Server. So very similar command, Docker container run, start me my application in a container, detach, put it in the background, publish the SQL Server port. So now I can connect to my container with any SQL client because it just looks like a remote SQL Server. I'm passing in some credentials there to set up how the behavior of the application works. So in this case, the SQL Server image, which again is owned by Microsoft, they expect you to provide an administrator password when you start the container so that you can actually administer it. And I'm giving it a name as well, so other containers can talk to it by its name. So now I've got a couple of containers running by container list. I've got my IIS and my SQL Server. So my SQL Server is publishing that port again, so I can connect to it. It's just like a remote SQL instance. So here, I've got a SQL client, and in here, I am using the same IP address. I'm using my standard, let's go down next, I've just changed that. Standard SQL Server port, and if I put in my password and connect, let's actually put in my right password. Let's try that. Hey, okay, so this is just basically an empty installation of SQL Server. So I can connect to it with any client or from another container, I can connect to it. And it's just an empty instance of SQL Server. But I haven't had to download the 6 gigabyte download and do the 4-hour installation. That's taken care of for me. And the actual the instance I'm running, which is just SQL Server Express, there are other options available. So Microsoft keep that patched. There's a Service Pack 1, there'll be a Service Pack 2 when they release. When there's a monthly Windows update, Microsoft keep that stuff patched too. So you can always use the latest versions. So that's just a really simple example of how this stuff actually works. Okay, so why is that useful? So I've taken somebody else's images there. So all I've got is a package, which one was IIS, one was SQL Server. I've brought them onto my machine, and I've run the container. And if you run those commands on your machine, you will have exactly the same behavior. You don't need any other prerequisites other than Docker. The only things you really need to know to get started with Docker are the kind of 4 main things. One is how do you actually package your application to run it in Docker? And that's with the Dockerfile, which is a really simple script. We'll see a few of them today. And all you do in that Dockerfile is you describe how to deploy your application. So you're going to say, copy in the MSI, run the MSI. Or you're going to say, copy in a zip file and extract it. Whatever you would normally do for your deployment document, except that it's scripted, and it's simple, and it's easy to automate. When you package your application, the output is an image. So the Dockerfile creates an image, which is one version of your application with everything that your application needs. It's got the version of the operating system that it needs. It's got any Windows features. It's got your application, your dependencies, your configuration. It tells Docker what to do when you start the application, all that stuff. That's the portable thing. So that's, logically, it's just one big file, and I can share that wherever I want, either publicly or on a private server. The way you share it is with a registry, which is just a server that stores these things. So there are public ones and there are private ones. You can run your own, and you can configure who has access to all these images. And then whoever has access runs the application in a container. And that's it. So the container is like an instance of the application running from an image, and the image is a store of one particular version of your application. Okay, so what I'm going to do for the rest of the session is take a really basic application and start modernizing it. So it's an ASP.NET web forms app that uses a SQL Server database. So if I was to run it as it is at the moment, I would need Visual Studio and SQL Server, IIS, the right version of .NET installed, all that sort of stuff. So I would need to ramp up my development environment if I just joined the project. I'm not going to do any of that. I'm going to go straight to Docker. So the first thing I'm going to do is I'm going to package up both those components to run in containers. So I'm going to have my database in one container and my web server in another container. I'm not going to change any code. I'm not even going to use the code for the first version. I'm just going to get it running in containers. And one of the benefits of that is that containers talking to each other is really cheap. So you can start breaking features out and put them in other containers and use Docker to glue everything together. So what I'm going to do is take one of the features out and put a message queue in between. So I'm going to make a synchronous feature asynchronous and run all that stuff in Docker containers. And then I'm going to break out a UI feature. I'm going to put it behind a proxy. So my original app is here, my asynchronous new feature is here, and the home page is going to come from a different component. So I'm going to start breaking this application out. Okay, so let's have a look at the application first. What I've got here is a Dockerfile for my application. This is version 1.1. What this is it's a really simple script. So the words in capitals are the Dockerfile instructions. You only need to know about 10 to be able to write a production Dockerfile. What I'm doing here is I'm starting from somebody else's image. I'm starting from a known starting point, which is Microsoft's ASP.NET image. 4.6.2, so I can specify exactly what version I want to run from. So that is Windows Server Core with all the latest Windows patches, IIS, .NET 4 installed, and ASP.NET all set up and configured. I don't have anything to do to get all my prerequisites. That's done for me by Microsoft. Then I switch to PowerShell. So the rest of the commands in here, I'm just going to run PowerShell commands. I copy in an MSI. So imagine you've already got a process that generates you a deployment package. In the Windows world, an MSI or a web deploy package. I'm just going to tack this onto the end of that process. It's going to show me how it works in Docker. Copying my MSI, and then I run an instruction to run MSI exec and deploy my installation file. So I'm doing that within PowerShell, so I've got control over when it starts and finishes. And so that's going to deploy my application. And then the other two lines are telling Docker what to do when somebody starts a container. So my image will have my packaged application from the MSI being installed. And I'm going to have this bootstrap script, which is a startup script, just a PowerShell script. So when someone starts a container, Docker will run that script, which is going to start IIS and make sure that the web server is still running. OK, so that's fairly simple. So what I'm going to do here is, where am I? OK. So I need to build my application into a Docker image. So I've got my Dockerfile. I'm going to run this Docker image build command. And what I'm doing here is I'm giving it a name, which is the tag, and I'm telling it where the Dockerfile is, which is that version 1 Dockerfile. So you'll see it executed all of those statements, but it was really fast because everything came from the cache. So when I said that Docker image, so at the end of this now, I've now got an image called sign up web v1. So that's my application package from the MSI. That is one thing, and I can ship that somewhere public. But logically, it's one thing, but physically, it's stored as lots of small things. And those small things can be reused and shared and cached. So what's happening here is because I've already run this same Docker command, this same Docker instruction, it's found that each of these instructions has already got a match in the cache. So it's going to reuse the cache. So what that means is it's super fast. So if you've got Docker at the end of your CI process, it's really quick because it will reuse as much of the cache as it can. So if your Dockerfile, if the only thing that changes is the final instruction, everything else comes from the cache and Docker just does that one thing. Okay, so now I've got my application. So now I can run it in a container, which is what this line is going to do. So same as I've already shown you, if I can get all the way across here, I'm going to do docker container run. I'm putting it in the background. I'm publishing port 80. So port 80 of my VM will go into my container. I'm passing it the credentials file, the same credentials file that I used for my SQL Server. So my SQL Server container is still running. And now my web container is going to talk to SQL Server. I've given it a name so I can refer to it easily. And then sign up web v1 is the image name, my image name. Okay, so that's running now. So let's just check. So I've got a web server, I've got my SQL Server, I've got my own custom web server now, all running in containers. So in order to see what's going on there, I can just browse to port 80. And I get this error. And it's okay, this is expected. So one of the problems with putting your Dockerfile in MSI is that it's not clear what's happening. So your Dockerfile really is your chance to take your legacy application, which currently has a 20-page PDF to deploy it, and get rid of that 20-page PDF and specify explicitly how to deploy the application. If I'm using an MSI, it's all opaque. I don't know what's going on inside here. It might not even be an ASP.NET application. Could be doing anything. The only hint I've got is that I'm using ASP.NET up here. So that's one of the problems. Now, actually, I know that I'm building an MSI from a Wix script. So if I go down here and have a look here, I can find out what's going wrong. I just need to scroll through this 300 lines of XML, and right down here, any second, I will see that I've got a virtual directory that deploys as part of the MSI. So what I need to do is browse to that. Okay, so now this is going to take a little while to start up. Why? Because Docker is just packaging it in the same way that I normally would. So at the end of this, I've got an image. When I start my container, Docker's going to start the IIS Windows service. That sits in the background. But there's not going to be a worker process until the first request comes in. So that's fast. I've got more to say, but it was too fast. But I'm going to carry on anyway. So it connects, the worker process starts, it serves the application. This uses Entity Framework code first. So it deploys the schema, it deploys all the reference data, and then the application gets shown. So all that stuff's happened while I've been talking. So this is my demo application. I've been using it all year. I'm sick of it. There'll be a new one next year. The tool that this talks about is real. There's a real tool called Image to Docker, which is a Powershell module that can generate Docker files for you. So you run this Image to Docker tool, point it to a virtual machine, and it will extract an application and write you the Docker file. But this demo app is a fake application to sign up for a newsletter. So this is coming from my web forms application. It's come from the MSI, so I haven't done anything. I haven't changed any code. It's all coming from the package that's in my Docker image. This stuff here comes from the database. So what's happened now is as I've run my application, it's deployed the schema, I know it's connecting to SQL Server because otherwise this wouldn't work. Okay, so if I put some stuff in here, say this is v1. Docker Inc. And click go. Okay, that saves the data to the database. So I can show you that by going back to SQL Electron. If I zoom back down and close my connection, connect again. So now I've got a new database in here, sign up, which is my sign up application that Entity Framework deployed. And in here, in my prospects, I've got the data that I've just put in. I've got my V1 data. So this is running in my databases in a container. It's really good for non-production environments. So if you've got a situation where at the moment you've got like a shared database, which just destroys your development workflow, you can give every developer their own instance of the database. You can have a database with your schema baked in. Just like my application is in my Docker image, my web application, I could have a schema baked into another image. But this is just using Entity Framework. Okay, so now I'm running in Docker. So that's pretty good. That didn't take very much effort. And that's given me a starting off point. So I'm here now. This actually already is useful because firstly I've got a distributable image. So version 1 of my sign-up web application, I can push that to a registry, public registry or a private one. I can dictate who has access to it. And then anyone who needs to run my app just runs it. They just do docker container run, same command that I've shown you. You can connect to SQL Server in a container too, or to remote SQL Server. Docker works fine with external services. And it'll be the same for everyone. And if I've got a bunch of test environments that in a typical large enterprise, you'll have you'll have UAT, you'll have system tests, you'll have time-travel environments, you'll have half a dozen easily. I can run them all in containers on the same server. I can get rid of a lot of hardware and condense it all, because they'll all just sit on the same machine. So my virtual machine has got 4 gig of RAM. I'm already running 3 containers. By the end of the session, I'll have half a dozen. It's fine. It just works. Okay, but my application is a legacy app, and there are problems with it. The first problem is there's a performance problem. So when I click that button to register my interest, the app makes a set of calls to SQL Server. They're synchronous calls. So I'll show you the code in a second. That doesn't scale. So now I've got my app in a container, I could run lots and lots of web containers, but if they all have a lot of traffic coming in, they're all going to try and make this synchronous database call at the same time, and they're going to find that SQL Server is a bottleneck. They're going to exhaust the connection pool, they're not going to be able to connect, and the users will see an error. So that's something that we could probably do with solving. The second problem is that if the users want to change some part of the UI, like if they want to change the home page and make it a bit funkier, they have to do a full release of the application, because it's a monolith. They have to go through all our system test environments and all those 6 environments. If there's a lot of manual testing, then that can take weeks. It'd be good if we could give them the ability to own their own front end. So we're going to look at that. And the last thing, very briefly, is at the moment, the process to build this stuff is complicated. So you've seen my MSI is built from 300 lines of Wix. Big, complicated applications will have MS build files that are equally large. They'll have a whole bunch of dependencies. They'll have a requirement to set up a build server, which needs Visual Studio and all sorts of stuff. It gets very, very complicated very quickly. And it would be nice if we could simplify that, especially as we're breaking things out and building more components. It would be good if it was an easy way to build those components. Okay, so first things first. Let's go and fix this performance problem. So the code that I was talking about is in here, in my web application, in the sign up code behind. So when you click that button go, this is what executes. It just populates a prospect object from all the stuff that the users put on the form. And as of version 1, it calls this save prospect code, which is the synchronous code here. So it uses Entity Framework, so it opens a connection to our database. And then Entity Framework is great, but it obscures a lot of what's actually happening here. So because I've got my using statement, so this block here, for the duration of this block, my code will be using a connection from the connection pool exclusively. And number of pools and connections in the pool is limited, so that's why this doesn't scale. So I'm looking up the country and the role as dependent objects, and then I do an add, and then I do a save changes. So there's at least 2 selects and 1 insert going on here. Now, it'll only take, it's sub-second, hopefully, but it still doesn't scale because eventually, if we've got enough traffic coming in, we're going to exhaust the connection pool. So what we do for version 2 is we publish an event instead. So I've still got my prospect that's populated in the same way, but now instead of talking to the database, I create this sign up event, which is just an object that is a message, and I publish it on a message queue. So I'm not going to go too much detail for the queue here. I'm using a public queue, public open source tool. I publish my event, and that's it. And that's super fast, and that does scale. Because if I've got hundreds of containers all doing this at the same time, all that happens is it takes 2 milliseconds to drop that event on the message queue, and then the server's ready to listen for the next request. But I need something on the other end. So I've got my web server is now publishing events to the queue. I need something to listen to those events and put the data in the database. So I've got another component now. This is like a simple way of breaking things down. So I'm integrating these components with a message queue, and the new component is just a console application. So again, it's a full .NET Framework console app. It's less than 100 lines, and most of them are boilerplate stuff. So what this does is it makes a connection to that same message queue, and then it listens for these type of messages. So it listens for these prospect signed up events. So this is just going to be a console app that's sitting there listening for message on the queue. And every time it gets a message, it uses this exact same code that came from the web application. So all I've done is taken that code out of the web application, put it in a console app, and glued them together with the message queue. And this is going to let me scale. And this is really easy to do with Docker because they're all going to run in containers. I don't have to worry about the amount of availability of the message queue or keep making sure that the console application is still running. Docker takes care of all that for me. Okay, so I need to rebuild some of my application here. So what I will first of all do is I'll build this handler. And I'll show you the Dockerfile for that in a second. So the handler is the message handler. That's the console app that's going to sit and wait and listen for messages and save them to SQL Server. Again, it's all come from the cache because I've already built this. But the Dockerfile for this is a little bit different than the first one. So the Dockerfile for my save handler, it uses the source code. So instead of having some other deployment artifact, like an MSI or a zip file, it goes right back to the source. So when I run this, there are two stages to this Dockerfile. The second stage just packages it up. So it's a little bit very similar to the previous one. I copy in the built application. I say that when Docker starts a container, it's going to run the exe. That's it. The exe is going to run and listen. And I give it an environment variable, like a configuration setting, where to find the message queue. But I just package it on Windows Server Core. I don't need any other prerequisites, so I can use a specific known version of Windows Server. The previous stage builds the application from source. So what I'm doing here is I'm starting from an image, a public image, that's got MS Build installed. So somebody else has written a Dockerfile, actually it's me, but somebody else has written a Dockerfile that installs MS Build, it installs the .NET deployment artifacts. Everything you need to build and package an application is in this image. So what I do in the first part, I copy in the NuGet package from my source into this image, and then I run NuGet restore. So that's going to give me all my packages in my image now. And then the last thing I do is I copy in the rest of the source and run MS Build to build my application. So what this is doing, the first part here is it's building my entire application from source. So now you don't even need MS Build installed on your machine to run and build this application. You just need the source code and Docker, because Docker will do the compilation for you in a container, and then it'll throw that container away, and the final output will just be your built application in this second image. Okay, so that's already been built, so that was nice and fast. I'm going to build a new version of my web application. So version 2 here is doing the, no, wrong one. Version 2 is doing the event publishing rather than writing directly to the database. Again, all from the cache. So if I change a line of code, then it would have changed, it would have rebuilt that particular step. So the Dockerfile for version 2 is a little bit more involved, but it's actually still not all that complicated. So I'm starting from ASP.NET, version 4.6.2, but I'm using a specific version of Windows. So whenever I build this, it'll use that version of Windows. And then instead of taking my MSI and letting it do the deployment, I'm going back to basics and doing it myself. So I'm going to run some PowerShell. I get rid of the default website, create a new website and a new web app. I can see my virtual directory name there because it's clear, it's in the Dockerfile. And then I've got an environment variable for my message queue location, so the web app knows how to find the message queue. And I'm copying everything that's coming from my published website, which again is in a previous stage. So this stage here builds the web project from source, and that's built in a container, so I don't need MS Build. And then it's in a published web deploy format. So the second stage can copy that out and deploy the web application. Okay, the other thing I've got in here is a health check, which I'll come to in a second. I'm going to start my application first. Okay, so I need a message queue, because that's the missing part. I'm going to have my console app, I'm going to have my web app. I need to glue them together. I'm going to start on message queue, and this is a public open source queue called NATS, which, if you want to look it up, is super performant, cross-platform, really good. There's a public Docker image, so the team who build NATS make this image available on Linux and Windows. So all you got to do to run it is run that. I've called it message queue, which is how the other containers will find it. So in their configuration, they're expecting to find their message queue on a server called message queue. And Docker has service discovery built in. So when the web container tries to look up that server, it will get the IP address of the container. And Docker takes care of that. OK, so I've got my message. Let's run my message handler 2. So now I've got my message queue and my handler that's going to sit there listening for messages, and now I need to update my web application. So if you're interested in my second session, which is after lunch, I'll be showing you how to do this on a cluster, which lets you do automatic upgrades and stuff. But because I'm on a single machine, I'm going to remove my web application container and run a new one from version 2. So it's the same command, but I'm using v2, or I would be if I copied it correctly. Okay, so Docker container run, put it in the background, publish the port, use the same credentials file, and then use v2 of the image. Okay, so now I've got a whole bunch of things running. I've got my original IIS application, which I'm not using anymore. And because I'm not using it, it's using very little resource. So that IIS container, which is down here, may be using 20 meg of RAM from my VM, but no CPU, because there are no requests coming in. So it's just like having an application in the background that's not doing anything. I've got my SQL Server, I've got my message queue, I've got my save handler that's listening for messages, and I've got the new version of my web application. Okay, so my web application, if you look here, I know it's a bit smunged up. It tells you how long these containers have been up. So my SQL Server has been up for 22 minutes. My web application has been up for 11 seconds. The web application has some extra information. It has this healthy flag, which tells me that Docker's tested the app, and it can tell that everything's okay. When Docker starts a container, it starts a process in the container, and it watches that process. And as long as the process is still running, Docker says the container's fine. So that's what's happening with my save handler. That console app is running inside the container. Docker knows that. It can see it's still running, so it thinks that container's fine. For a web application, it's slightly more complicated because my web server could be up, but it could be maxed out. It could be returning a 503 to every request. Docker thinks it's fine because the process is still running. So what the health check does, which I skipped over, is it lets you tell Docker how to test your application is really healthy. So what this is doing is saying every 5 seconds, when you run a container, every 5 seconds run this command. So just make a local web request, and if the response is 200, then return 0. Tell Docker everything's okay. If the response is anything else, a 503 or a 404 or whatever, unexpected, or there's an error, executing that command, return 1, and then Docker knows the container's not healthy. So this Dockerfile here, which comes to all of 33 lines, builds from source, packages the application in a way that's really clear what's happening, and it tells the runtime how to test the application is actually healthy. So this, in one file, which could be jointly owned by the dev and the ops team and the security team, it defines the whole operation of the application. And the other thing about this, because this runs every 5 seconds, firstly, it gets rid of the warm-up lag, because by the time the first user hits my website, it's already warm, because my constant polling has already warmed it up. And if you're doing things like caching inside your application, this takes care of clearing the expiration and making sure your cache is up to date too. So it's really handy having that health check. Okay, so let's browse to version 2 of my application. So it looks the same. It starts really quickly, but now I'm version 2. If I go and click sign up again and do v2 and put in any old stuff, and click go. So the behavior is different now. From the user perspective, the UX is exactly the same. I see the application, I put in my details, I click go. What's happening now, though, is the web application has dropped a message onto the message queue. It's published an event to say somebody signed up, and then that's it. The web server has no more to do with the database. So if I go and update my query, and zoom in, so now I've got v2. So the output is the same. So from the user's perspective, it's the same. From the operations perspective, it's the same. I've got my data in my database, but now it's gone through the message queue. And I can prove that by looking at the logs inside my save handler. So that's called 219. So if I look at the logs for this container, it tells me this is the stuff that's coming out from my console write line statements in my C# project. So I'm connecting to the message queue, I'm listening for these type of events, I've received an event, I'm saving the database, and I've got my prospect ID back. So that comes from after the save. So I've rerouted this particular part of my application. I've changed the architecture without having to completely rewrite my app. I've just taken one feature out and put it in a different place and glued them together. Okay, let's just switch back to the demos. Okay, so version 2 of my app, the architecture's evolved now. Instead of just having my monolithic application and my database, I've now got, I've split out one feature and I've glued them together with containers. So this is my message queue container. It uses NATs, as I said. It's really highly performant. And one of the things about this particular pattern, so moving from synchronous database usage to asynchronous is like page 1 of enterprise integration patterns. But it's usually a nightmare because I've got my web application. It's highly available across X number of servers. If as a developer or an architect, you suggest putting in a message queue, then immediately you've got to talk to the ops team because your message queue needs to be highly available too. And you don't want to run those on the same servers as your web server, so you need more kit. And suddenly it becomes a huge project just to make this small architectural change. Also, if you're in a big enough company, you've probably already got a message queue, but it might be something like WebSphere, or you might be using MSMQ or whatever you're using, that doesn't really fit in every environment. So if you're using an expensive message queue like Tibco to get your production performance, you're not going to have that in your test environment because it's too expensive. And you're certainly not going to have it on a dev laptop because you wouldn't be able to run it. So by moving your message queue into a container, what you get is the message queue has exactly the same availability characteristics as the rest of your application. If you're running across a highly available swarm, your message queue is highly available too, automatically. And you can use the same technology everywhere. So instead of writing a bunch of code, which I've written several times, to say, I need to use a message queue, but I don't know which one it is, and it's going to be different in every environment, so I need to write an I message queue and a message queue factory and a bunch of implementations for all the things that we actually use, you throw all that away, because it's the same everywhere. You don't have to worry about differences between your infrastructure components, because they're the same. Okay, so we fixed that, hooray. Now I can run lots of web containers. If I've got a huge amount of load coming into my application, all that happens is the message queue fills up, and then the handler will gradually work its way through them. So now I'm relying on my message queue to keep those messages safe, but that's what a message queue does, so that's fine. Okay, so next, I've got my, my UX. So I need to fix my problem with the fact that if I just want to change the UI, change the color of the home page, then I've got to do a full release. And if it's a big enough application, that could be a 2-week process. And that's not a lie. So when you get to big enough applications, they take an entire weekend to do the deployment. They take weeks and weeks of UAT to make sure nothing breaks beforehand. And you only do them 3 or 4 times a year because they're so expensive. If you can break these components that need to change frequently out and put them somewhere else, then the only thing you need to test for that release is the something else, the small UI component. And that's what I'm going to move to here. Okay, so next demo is splitting out my front end. So I'm going to give users the ability to own the home page themselves. So currently, when you browse to the web application, it's an ASPX home page that's generated from my monolith, and that's the development team who own that. It'd be good if we could give the users a content management system. So they own the home page, and then when you browse from the home page to the registration page, then that goes back to the original web app. That's what I'm going to do here. So I've already packaged, there's a fantastic open source CMS called Umbraco. There's a D at the beginning of Docker, I've noticed. So I've already packaged that. Again, that's a public image that you can go and play with. It's up on Docker Hub. So now I've got Umbraco running in a container. So I can browse to my same web server. I've published port 8088 instead of 8080. So I can browse to that, and I can see what's actually inside my Umbraco setup. So packaging for Umbraco is just exactly the same process. So I've got a Dockerfile that downloads Umbraco from the website. So I've just followed the deployment process that's on their website, but I've automated it. So in my Dockerfile, I download the zip file to deploy Umbraco, I install it, and then I've also configured my home page. So I've done like the first cut of this delivery, and I've got a home page which looks more like what I want, because it's very 2010, which is a lot more modern than the previous one. So this is what the new homepage looks like. There's some words there, and if I want to, I can click on this, and it scrolls down nicely, and it would work on a mobile device. And then this button is going to take me back to the registration page. Now this is just the CMS container, so there's no integration at the moment. It's just running on its own. So if I click on this, I've put the right link in, but there's nothing happening because I'm trying to browse to the product launch application, but there is no product launch application. So I've got a separate component for my home page. I've got my original application, but I've got nothing that's gluing them together. So I need something at the front to make that happen. And that's a proxy. So what a proxy is going to be the entry point to my application, and it's going to direct traffic either to the home page container or to my original application container. And again, I'm using a fantastic open source product called Nginx, which is my proxy. So that's going to be in a container too. Okay, let me show you how this looks like. So what I'm doing is I'm breaking out a UI feature, and I'm using another container to glue them together. So at the front end, I've got a container at the start, which is just an integration component. My proxy is just going to route traffic to one container or another. And then when I get to my web application, I've broken out the back end, and I'm using a message queue for my integration. So I'm using different types of ways to break these features out. Okay, so now I've got my proxy running. Let me show you what that looks like. So in my proxy, the Dockerfile is similar to what I've described. I go and download the zip file to deploy Nginx, and then I copy in my configuration. So my configuration is going to tell the proxy where to route traffic. And if you're not familiar with Nginx, like a third of the internet runs on it. It's a fantastic product. And actually, it's pretty simple to use. So the interesting bit is the server block. And all this is saying is that Nginx will listen on port 80, and when it receives any requests for the home page, pass them to the home page container. And when you receive any requests for the product launch route, then route them into the original web application container. So that's it. That's all I need to do. There's nothing clever going on here. If I were to break more and more features out, all I would do is put more and more locations in here. Because Nginx is running in a container, it can access the other containers by their name. So now when I go to production, the only thing that's publicly accessible is the proxy. That's the entry point to my application. Everything else lives behind in the Docker world. So you can't get to my CMS unless you explicitly allow access to the CMS. Okay, so now my proxy is listening on, what did I say? 1890. So if I browse to 1890, okay, so this is now, I'm talking now to the proxy. So I've hit the proxy, I've hit the home page request, and it's routed that to the home page container. So this is coming from my CMS, okay? So now when I browse down here and click on sign up, then it goes back to my web application container. So that's a different route, so it's sent it into a different container. So I'm breaking these features up and just plugging them together with the proxy. So if I do a v3 here, and a v3, is it v3? I think it's v3. And click go. It's the same behavior. If I go and check my database, then my v3 will be in there. So it's the same application in the same way. All I've done is I put an integration component at the front end, which lets me break up my UI features. Okay, so, and because I've got this proxy, it's talking to my CMS, then the business owners can own the content of the home page now. So I'm talking to my CMS container. I'm going to browse, and I'm going to use my special password, which is umbraco admin, and log in. And this is what the users will see. So now I can say to the users, okay, we've done the new deployment, we've got your funky new home page, and now you're in charge. Like, you don't need to do anything to release a UI update. If you've got something really important to do, like putting an exclamation mark there, you do save and publish. I go back to my proxy, and there's my updated content. They can, and everything's coming from the CMS, so they can do the styling, the content. They can have more rich stuff in here, like a contact page and a blog. They can do all that stuff. And it's only when it comes back into the transactional world of storing the data that we flip back to the original application. And Umbraco has a really nice authentication system, so you can define who can do what, and a workflow and all that sort of stuff. So you can tighten that stuff down and just use all those features in that great open source product without having to do a whole bunch of work yourself. Okay, so application's a bit bigger now. There are a few more things going on. So here's my original web app. And I've broken out the save feature and put it over here. And I'm no longer using the home page in the app. I'm using the home page from Umbraco. And so my integration component at the back end is my message queue. If I wanted to, I could have more things that I'm attaching here. So I'll do that in my second session after lunch. I'll add another event message handler here, which will subscribe to the same events and do something else. I don't need to change anything to do that deployment. It's purely an additive release, so I'm just going to run more containers. If I want to break out more features here, then I can do that by running more containers at the front end and just change the routing rules in the proxy. So without doing a whole lot of work, and you'll see if you look at the repo that most of the code is in here. Excuse me, I've broken out about 100 lines here. I'm using open source technologies here and here and here. So it's all really gluing together nicely and taking advantage of what Docker lets you do. Okay, so I fixed that. So the last thing is, now I've got these 6, 7 containers. I've got different things that need to be built and packaged. How do I manage that stuff? Because you're in danger of saying, well, we've got all these things, and we've got some automation scripts, but they're thousands of lines. And they use 10 different technologies, and they're impossible to manage. So just automating stuff isn't the end goal. Like automation, if you automate it and you're using a whole bunch of technologies and thousands of lines of script, you've just moved the problem from humans doing the work to humans managing all these scripts. So it's really nice if you can make this simpler. So that's what I've got here. So I've been running individual containers to make this stuff happen, to release it and to build it. But actually you can use another tool called Docker Compose, which lets you define the whole application in a single file. So my Dockerfile describes how to build and package a single component. So I had a Dockerfile for my web application, I had a Dockerfile for my message handler, a Dockerfile for Nginx, all that sort of stuff. The Docker Compose file lets you describe a multi-container application in a pretty simple format. So what I've got here is each component is listed as a service, and I just list all the configuration values that I already put in to when I do a Docker run command. So my database, I'm using SQL Server, I'm exposing the port, I've got my credentials file. My message queue is just nats. My save handler is my message handler, my console application. This is my own, because this is my own image, I can include stuff here that tells Docker how to actually package the application. So I'm saying when you build this, that's where you'll find the Docker file. And then my home page, that uses Umbraco. My web application, again, that comes from my own Docker file down here. And it depends on these other things. So I can capture the fact that these things need to start in a particular order, and that if one of them gets replaced, the others that follow on down should also get replaced. And the final thing is my proxy, which is my Nginx. There's my Dockerfile, and this has got port 80 exposed. So this is more like this is my document that's going to deploy this to a test environment, because the only thing that's publicly available is the proxy and Umbraco, which is on port 8080. Wherever it is. And so you can't actually get to the web application directly. You have to go via the proxy. And because I've got these spins about how to build it, doing a CI for this now becomes really incredibly simple. So my CI process, let me get rid of all this, and I'll do a full new deployment. So this command, docker container remove, and remove everything from this other command, which is listing all the containers. So just kill everything. So now I've got no containers running. So if I do a container list, now it's empty. Okay, so I'm going to use this other tool, Docker Compose. And if I go in here, this is where my compose file is, which is just that YAML file that I've showed you. If I do a Docker Compose build, it will go through, and anything that's got a Docker file listed in that compose file will go and get built. And again, it uses the Docker service, the Docker API, so anything that's already cached gets used from the cache. So it's been through and done all this stuff for me. So this is your CI process. So your CI server just needs to have Docker, doesn't need MS Build or Visual Studio or any of that stuff, just needs Docker and the source code. And then your command to build your entire project is that Docker Compose command. And then to deploy it, you do Docker Compose up, and -D puts them in the background. And it's going to go through and start all these things. So what Docker Compose does is it takes your compose file as the desired state, it looks at what's currently running in Docker, it finds the diff, and then it creates whatever it needs to create to make it to be what you want it to be. So in this case, I had nothing running, so everything gets created, but they're created in the right order. So my proxy doesn't get created until everything else is done, and my web app doesn't get created until my database is done. So now, let's do have a look at all my containers. So I've got all these things running again. I've started my entire application, and this would be the next stage in your CI process. So stage 1, you do that build, single command. Stage 2, you deploy everything on the CI server, again, single command. Everything runs in containers. And then stage 3, you run a container that's got all your end-to-end tests in there. So if you're using SpecFlow or NUnit or whatever, you can have a whole bunch of end-to-end tests that run inside a container. They browse to the proxy, they simulate a user using the application, they put some data in, and then they query SQL Server to make sure the data's there. And because everything's running in containers, it's completely throwaway. At the end of the test stage, you get rid of them all. And then there's no danger that the next build, the database won't be contaminated. So you can do proper integration tests that really write to the database and really check the data's there, because you know that the next time that test runs, it'll be a completely empty database that's come from a new container. Okay, so all my application now is running on port 80. So that's coming from the CMS. Notice that the exclamation mark's gone because I've gone back to the original container. So I've lost those edits because they were part of the different container. I can click sign up, and here's v4. And, oh yeah, I've got Lithuania in here now. v4, and exactly the same behavior. It's going to go to my message queue. It's going to go and the handler will go and put it into my SQL Server. I got a new SQL Server database because I killed the old container. I've started a completely new, fresh one. So the application has deployed the schema, reference data, et cetera, and I've only got one line in here now because this is from my new test deployment. So everything is now running inside these completely separate sets of containers. And when I'm ready, I just do a docker compose down, and that gets rid of my containers, kills everything, clears it all up. So I've got nothing running now. So that is your CI process. Because the Docker command line is separate from the Docker API, you can, like I'm doing now, I'm connecting my Mac to my virtual machine. I could be in my CI server connecting to a remote Docker server. And I could deploy using exactly the same set of scripts. So I could say, now I switch to my test server and I do Docker compose up, and it's going to upgrade everything in my test server. And so your CI process is a couple of lines. Your CD process is a couple of lines. And you can use whatever tool you like. VSTS or Jenkins or whatever, they've all got Docker plugins, and as long as you can use a command line, you don't even need a Docker plugin. You can just run those simple commands yourself as part of your CI. Okay, so fix my process as well. So I've got ticks for all of these things, so that's a pretty good hour's work. So the last slide, which is really fancy, it's got all these colors in it, and it sort of builds up as I go. So it's about the process of doing this modernization. So I've shown you a few simple examples, going fairly fast, I realize that, but I've taken my monolithic application, I fixed a performance problem by breaking a feature out and gluing them together with Docker. I fixed a release problem, a business problem. They couldn't get changes out to their homepage. I fixed that by breaking a feature out and putting a proxy in front. So I've got all these containers now. Not doing a full re-architecture. Thank you. Not having to do like a 2-year project to move to microservices. I've just looked at the things that are causing problems and addressed them specifically. And by using Docker, it's made it really easy to glue things together. So this is the modernization spectrum. I've got this big old legacy application, and I'd kind of like to move to microservices and an event-driven architecture, but I haven't got 2 years to do that. And perhaps not all applications justify that. So the idea here is that you can go, it's not a progression. It's you land wherever is appropriate for each of your applications. So if it's a genuine legacy application that is no longer being developed, but is still being used, you just land here. Like the very first Dockerfile that deployed the MSI, that's now giving me something that I can run in a container. It's a monolith running in a container, but that's okay, because I've still got the benefits of that. I've got my image that's portable. The image format is well understood, so my tools can do things like security scanning, and I can share that with whoever needs it. And when I run it, it's going to run in a lot less hardware requirements. But then if I start to make more use of Docker, I can hopefully do things like bring the configuration rules of the application and the logging, bring them into Docker without changing code. But then if I do want to change code, I can start doing some more interesting stuff. Like I can make it more Docker aware and start moving further down here until I got to the point where I've done my microservice re-architecture. But I can do that at a kind of value level. I can look at all the features that are important and do them one at a time. And at the end result, I've got maybe where I wanted it to be, and I can start using whatever technology is appropriate. Because inside those containers, Docker can talk to those containers on any machine in a cluster. So if you've got Docker running on 5 servers, and some of them are Linux, some of them are Windows, which is what I'll be talking about after lunch, then they can still talk to each other. So I could have .NET Core running in a Linux container over here, and SQL Server running in a Windows container over here. And they're talking exactly the same way. Okay, so I did have a few questions coming in, but this screen went off, so I stopped paying attention to it. So let's see what's going on here. Cool, okay, so 2 questions. This is the next steps, and I'll take questions now. If you want to see the progression of this kind of modernization stuff, this is a bunch of videos that are on YouTube. So that MTA IT Pro takes you through taking an existing application, how to integrate configuration and logging and all that sort of stuff. If you want to go and look at this, if you want to do a more in-depth view of your own having a go at this, there's a workshop that I do, and the content of that is all on GitHub too. So it's a full-day workshop, but you can go and work through it in your own pace. All you need is Windows 10 with Docker installed, and you'll be able to do all that stuff. And if you want us to come in and help you, then we have this funded program where we come in with some partners and take a legacy application and show you how it works in Docker. Okay, I've got 2 questions here, and then I'll take questions if you've got any. So, from Anonymous, some time ago, Docker was considered good for development, but unstable in production. Is this still the case? Well, no, obviously. I mean, I would say that, right? But Docker on Windows, Windows Server 2016 has got Docker support. And that came in with the release at the end of last year. With Windows, you get the Enterprise Edition of Docker. So Enterprise Edition, there's the free edition, there's the Enterprise Edition. Enterprise Edition has a paid license, but in our deal with Microsoft, you get Windows Server 2016, you get Docker Enterprise Edition as part of your Windows license. That's supported for production. So we've got clients running Windows containers in production. Some of them, they've used that whole spectrum that I've been showing you. Some of them are in the red zone, where they've just taken their application and run it in a container, and some are moving towards the purple zone and breaking this up into other things. Docker emerged in the world of Linux, and it's almost 5 years old now, Docker, the platform. And the Docker code base is written in Go. It's cross-platform. It's the same code that runs on Windows as it runs on Linux. So there are differences, because when you create a container, you do it this way in Windows and this way in Linux. But it's a stable platform that's in production use in some of the biggest companies in the world. So that sounds like it was a planted question, but it's a genuine question. Okay, next one. What Linux environment is good to run Docker for production? Great question, because it doesn't really matter. So if you're running in containers in Linux, you can use whichever flavor of Linux makes sense for you. So I use Ubuntu because that's the one I'm familiar with. That's the one I've used for years. Inside the container, you can use a really stripped-down version of Linux. So there's a distro called Alpine. If you run a container based on Alpine, it's about 3 megabytes for the entire operating system. Compare that to 12 gigabytes for Windows Server Core. So there's a difference there. Alpine gives you some benefits, and you lose some other advantages. So it's entirely up to you, but Docker runs on all of them. Like for Linux, the only requirement is you need kernel like 4 point something from 2 or 3 years ago. So if you're using Ubuntu, Red Hat, SUSE, whatever, Docker works for all of them. So whatever's comfortable with your Linux experience. But do try and make sure you get it from Docker Store, which has instructions for each of the distros and how to deploy it. Because if you do it from sudo apt-get or whatever, you're going to get an older version of Docker. So back at the beginning of last year, each distribution kind of packaged up Docker itself. So Ubuntu have it from apt-get, and from the other distributions. But then we kind of made it easier to own it ourselves. So Docker Store tells you how to download it. It's still community edition, still free, but it's the latest version. Okay, any other questions? No? Cool. Okay, I've got some stickers. I've got some Pluralsight passes. I've got a copy of my book, if anyone wants to take that. I've only got one. And after lunch, I'm doing a session where I take the endpoint of this morning's session and I deploy that to a swarm, to a cluster of machines. And I talk about high availability, and I talk about moving things between Windows and Linux. Like all the demos worked this morning, and this afternoon they won't work. So if you want to see me having a lot less fun, come this afternoon, because there will almost certainly be problems. Which, more fun on this side of the projector. And if there's no more questions, thank you very much. Oh yeah, excellent. How does licensing work when running Windows containers from a Mac? So firstly, I'm not running Windows containers on a Mac. I've got a Windows Server virtual machine. Okay, so I've got a virtual machine running inside Parallels. You pay for licensing based on the server. So if I'm running Windows Server 2016, if I'm running 100 containers on there, I pay for 1 Windows license for the server. And that's, if I've got 10 servers and I can run 1,000 containers, I pay for 10 Windows licenses. So one of the big reasons people are moving to Docker is cost. Like, it's boring, but it's really easy to work out that if I'm running my applications in a single VM because I need to be isolated, I'm probably running a lot more VMs than I need. So if I can get rid of half of my VMs, which a lot of our clients do, they move everything to containers, consolidate, get rid of half their VMs, and plus now I don't have the Windows licenses either. So cost is a good thing. Okay. Is that really it? Cool, and enjoy your lunch. I'm around all day. Thank you very much.